Good morning, everyone. I am Steve,
And I am Scott.
and together we are Backyard Musings, Apple Valley, California.
Still the Science and Technology channel.
We're still slinging science and technology.
Yep.
We're the messengers, so don't shoot us.
And having a
And
good time.
if you could help us by clicking that like button. I guess it has something to do with the algorithms. People can view it more, or they get it on their hits. So I really don't know about the algorithm, but that's what I hear. So click the like button. Encouraging advances in predicting how patients with major depressive disorder, MDD, will respond to antidepressant treatments using brain imaging and clinical data. Finding an effective antidepressant can be a frustrating and lengthy process, often requiring individuals to spend weeks on medications that ultimately prove ineffective. However, a new study offers hope for a treatment more personalized approach to treatment. Published in JAMA Network Open on March 20th, 2025, the study presents promising advances in predicting how patients with major depressive disorder will respond to antidepressant medications. Would you like to know more?
By combining brain imaging with clinical data, researchers found that patterns of brain connectivity, particularly within the dorsal anterior cingulate cortex. Okay, dorsal, that's the only thing I know about dorsals is fins on fish.
Yeah, say that 3 times fast.
Yeah, significantly improved the ability to predict treatment outcomes across 2 large independent clinical trials.
Quote, in spite of the availability of several antidepressant treatments, including medications and psychotherapy, many individuals with depression have difficulties finding the treatment that works best for them, said Diego Pizzagalli, a PhD, director of the Noel Drury MD Institute for Translational Depression Discoveries at UC Irvine, and the distinguished professor at Charlie Dunlop School of Biological Sciences and the School of Medicine. Not making that name up. Diego Pizzagalli.
At the University of California, Italy. All right, quote, as a result, for many, treatment follows a trial and error approach, discovering brain-based markers predicting positive antidepressant response promises to allow a more personalized treatment and thereby speed up reduction of symptoms, unquote. So this has been a big deal, right? Depression is, it's like it's coming on strong. A lot of people have anxiety about things. They're depressed about things. So, yeah.
So it's a real thing. It's hard to understand if you don't have depression, but it's a real thing. The research team used machine learning models trained on clinical and neuroimaging data. So machine learning, that's AI. Again, we're seeing so much developments in AI. From over 350 participants enrolled in 2 international studies, Embark in the US and CanBind1 from Canada. They tested whether their algorithms could accurately predict who would respond to commonly prescribed antidepressants, such as sertraline and escitalopram. I know about escitalopram. I used to take escitalopram.
And what did you take that for, if you don't mind me asking?
Mood control. Mood control.
Was it prescribed?
Yep.
Huh.
But it had some side effects that I didn't like, so stopped taking it.
I mean, that you can't hardly take anything nowadays that's prescribed that doesn't have a list of side effects as long as your arm, right? And some of them are pretty bad. So they found adding a brain connectivity marker to traditional clinical data such as age, sex, and baseline depression severity significantly improved prediction performance across both studies.
Okay. Quote, we identified a brain connectivity marker that was predictive of response to common antidepressants across 2 large-scale clinical trials in the U.S. and Canada, explained Peter Zhukovsky, not the Zhukovsky from Flash Gordon, a former postdoctoral fellow in Dr. Pizzagalli's laboratory and now scientist in the Brain Health Imaging Center at the Center for Addiction and Mental Health, and first author of the study. The quote continues, the predicted performance of our algorithm was improved by the addition of the brain connectivity feature to clinical and demographic markers, reaching moderate levels. Our findings are promising for the search for biomarkers predicting depression response. We hope these efforts will help connect patients with treatments that are most likely to work for them.
The study also tackled the most often overlooked challenge of generalizability, whether a prediction model developed in one trial will hold up in a completely separate population. That's where this research stands out. Models trained on one trial performed surprisingly well when tested on another, highlighting the potential for broader real-world use.
Okay, here's another quote. Data harmonization and building a large-scale database with different treatments is challenging, noted Dr. Zhukovsky. However, we're hopeful that cross-trial analyses, such as the one we conducted in this project, will advance precision medicine goals.
Study's implications are far-reaching. By developing biomarkers that are not limited to one treatment setting or population, researchers are laying the groundwork for clinical tools that could eventually match patients with effective treatment earlier, potentially reducing suffering and speeding recovery.
Oh, that's cool.
Yeah, that's good.
I like that. Another quote here, we investigated biomarkers predicting antidepressant treatment response, Zhukovsky added. However, many other options are available for treating depression, and if we can identify markers for specific treatments, then the resulting decision support tools could be tested in biomarker-guided clinical studies.
As mental health disorders continue to rise globally, like we were just talking about, the need for faster, data-driven treatment approaches is more urgent than ever. The team's findings underscore the promise of brain-based diagnostics to transform how depression is treated, but they also stress that more research is needed. Larger trials, new treatment comparisons, and real-world implementation studies to bring these insights from the lab to the clinic. This line of work will be one of the key priorities within this recently launched Noel Drury, MD Institute for Transitional Depression Discoveries at UC Irvine.
Yeah, I hope they can do something with this. You know, depression is real.
Yeah, so my wife was listening to an instructional video the other day about diabetes and the different types, and they mentioned that they are deeming Alzheimer's or dementia a type 3 diabetes. Yeah,
Really?
I found that kind of weird. Maybe we should look into that and do a segment on
Yeah.
We've talked about that type 1 and type 2 in the past, and of course Alzheimer's and depression. So
That sounds fascinating. Yeah. Yeah. Well, I'll do some research, see if I can dig something up.
Or our producers will do the research.
Yeah.
Hey, there's our producer now.
Cameron, what are you doing?
Cameron, nice shades, man. All right. Good.
All right. Thanks. We'll catch you in the afternoon.
Take care, everyone. Thanks.